Before jumping into this problem, or really any limit problem, I really recommend that you take a moment to look at the function that you're trying to take the limit of and really see what it is you're working with. So in this function, I notice that it's the ratio of a couple of different functions, and the top and the bottom both have the exponential e to the x that appears. But see, it appears in a couple of different ways. See, in the bottom, we do see an e to the x term, but in both the top and the bottom, we see not just e to the x, but rather e to the 2x. So now e to the 2x we can interpret as e to the x, where that whole term there is squared, e to the x in parentheses squared. And that is really indicating to us that what we have on both the top and the bottom is really a polynomial on the top, a polynomial on the bottom, where our variable is e to the x. Because we have different powers of e to the x, especially there on the bottom we see. And so, of course, when we're computing limits, usually we want to just see what's happening if we, quote, plug in and see what we get. But what we're going to get here is if we plug into infinity, remember what e to the x looks like. Well, e to the x is like this exponential growth thing. We are looking at end behavior, so we're looking at it as x goes to infinity. So we're looking at the right-hand side here. So the arrow that we're considering is this one that's going up without bound to positive infinity. So whether we are looking at e to the x or e to the 2x, we're going to go off to infinity because it would just be like infinity squared in that sense. So what we have here on the top would be the constant 1 minus the constant multiple 5 times infinity would just be the infinity. So we're looking at 1 minus infinity on the top. In the bottom, each of the two terms are added together and each one goes to infinity. So infinity plus infinity itself is not indeterminate, but the problem here is a constant minus infinity is negative infinity. So the fact that we have the ratio of some infinities here is that this is an indeterminate form. So we can't just get an answer by plugging in and interpreting. So we need another approach here. And so this is where I recommend noticing that those different powers of e to the x are really giving us this polynomial-like thing. And so one of the techniques that we used for rational functions where we had a polynomial over a polynomial was we identified the highest power that appeared in the bottom, and we divided all terms by that. And so the highest power of e to the x in the bottom is that e to the 2x. And so what we're going to do then is we're going to divide all terms by e to the 2x so that we can set this algebraically up to get something that's not indeterminate. So let's do this. What we end up with here is the limit as x goes to infinity, and I am going to write this extra step just to show you what it is that I'm doing. So I'm just copying over my function here, and I notice that in the bottom, my highest power of e to the x was that e to the 2x. So what I'm really doing is I'm dividing all terms on the top and on the bottom by that highest power, e to the 2x, that's in the bottom. So of course that needs to be distributed, so we're going to do that on both the top and the bottom. And what we get there on the top is the constant 1 over my e to the 2x. And then we have the 5 e to the 2x divided by e to the 2x. On the bottom of this, we would have the 3 e to the x over e to the 2x. And then we'd have plus 4 e to the 2x over e to the 2x. So that's where we are doing the act of dividing each term by e to the 2x, where e to the 2x was that highest power of e, or highest power of e to the x that we had. All right, so let's go ahead and reduce out each one of these terms. That first one there doesn't need any reducing, so we've got just the 1 over e to the 2x. The second term, we've got e to the 2x on both the top and the bottom, so those would cancel, leaving us with the constant 5. On the bottom, we've got an e to the x over an e to the 2x. So really remember that e to the 2x is like e to the x times itself, so it's squared. And so we've got one copy of e to the x that cancels leaving us with just the 3 on the top and just the e to the x now, not e to the 2x, because we canceled one of the factors of e to the x on the bottom. The last term on the bottom has e to the 2x on both the top and the bottom that would just cancel out, leaving us with 4. Okay. So, remember what we have as our graph. The graph here that I drew, I should probably label it. It's y equals e to the x. All right? So we know that as we go off to infinity, e to the x goes off to infinity. So as x goes to infinity, so does e to the 2x, or so does e to the x. So what we're looking at when we are computing this limit then is a 1 over, all right, we've got e to the 2x. Well, we said e to the x went off to infinity. Squaring it's going to keep it going off to infinity. So we're really looking at a 1 over infinity situation. That's going to be the first term on the top minus the constant 5 on the top. And then on the bottom, we've got the same sort of situation. That 3 over e to the x, well, e to the x is going off to infinity. So we're really looking at like a 3 over infinity. And then we've got the, not plus 5 this time, plus 4. All right? So anytime we are dividing by infinity, we think, again, infinity and 0 are kind of reciprocals of each other. So if the denominator is blowing up, then the fraction itself is going to 0. So we're looking at a 0 minus 5 over 0 plus 4. And so that arithmetic we can do without any trouble at all. And so we've got negative 5 over 4 as our final answer here. Now, taking a look here at the perspective of the problem, notice that what we have really said is very similar to what we could say for just a regular rational expression without e to the x in there. The highest power term on the top over the highest power term on the bottom is dominating. So see that term that is the negative 5 e to the 2x on top is what was dominating the direction really for the top. And then the bottom, the highest power there was the highest power term there was our 4 e to the 2x, and that's what kind of persisted as we went through this. So that was the term that was dominating our bottom. So then it ended up that since those powers were the same, for that highest power term on e to the x, the ratio of those coefficients ended up being our answer for the limit. And so that's really not by accident. That is what's happening on this problem, but we can see algebraically, without kind of doing anything magical, that is our answer with the full justification there.